The most important chip in artificial intelligence was designed to play video games. The hardware behind ChatGPT, Midjourney, basically every large AI model you've ever heard of started as a graphics card. NVIDIA became a $3 trillion company selling these chips. Governments are subsidizing them. The world is fighting over the supply. But the question that gets skipped every single time? Why does a chatbot need a gaming chip? The answer is one of the best accidents in tech history. To fully understand it, you need to know what AI is actually asking the hardware to do. And it's actually simpler than it sounds. At the core of every neural network is a single operation repeated billions of times: matrix multiplication. But what exactly does that mean? Well, everything a model has learned is stored in a giant grid of numbers. And whatever you feed it, a word, a pixel, a sound, gets turned into a list of numbers too. To produce an answer, the model takes your numbers and runs them through those grids. And yes, this is literal multiplication. Take one of the numbers, multiply it by one number from the grid, and do that all the way down the list, adding every result into a single running total. Multiply, 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 then sum. Thousands of those, back to back. Each pass blends your input with what the model learned during training, and what comes out becomes the input to the next layer. Stack enough of those layers, and a sequence appears, or an image, or a voice. And that's the entire engine at work, multiplying huge grids of numbers, adding the results into one total, then doing it again and again. Multiply, add, repeat. It's not magic, just that same little calculation at a scale that's almost impossible to picture. And you may know this, but your computer already has a chip that does math. It's the CPU. It has 8 to 16 cores, each one powerful, built to race through complex problems in order, one step at a time. Put all those cores together, and they handle about 1 to 2 trillion operations per second. That sounds enormous. A GPU clears over 100 trillion operations per second on the same kind of work. Not a little faster, 50 to 100 times faster. Why? Think of a CPU as a general contractor. Brilliant, precise, capable of anything on the site. Read the blueprints, make the judgment calls, handle the one tricky step that changes everything downstream. Now, think of a GPU as a crew of 1,000 workers. Each one can only hammer nails. That's their whole job. Hammer nails, all at once, as fast as possible. For most of what a computer does, running your operating system, loading a page, responding to a click, you want the contractor. The problem needs care, sequence, judgment at each step. But AI math? It's all nails. Billions of identical multiplications that don't depend on each other. You don't need a contractor for that. You need 1,000 hammers working simultaneously. A GPU has thousands of cores, each one simpler and slower than a CPU core, but all running in parallel. That's the trade-off. The CPU gets one thing done fast. The GPU gets a mountain of identical things done at once. GPUs weren't built for AI. NVIDIA released the GeForce 256 in 1999, the first chip to carry the name GPU. And it was designed entirely for video games, specifically to render the pixels on your screen in real time. A 4K display has about 8 million pixels. Every frame, each pixel, needs its own color calculated independently, simultaneously, at 60 frames per second. That is the same shape of the problem as a neural network. Millions of small, identical calculations that can all run at once. The math that draws a game and the math that runs an AI turned out to be the same math. Nobody planned it. It was an accident. The proof came in 2012. A team trained a neural network, AlexNet, on 2 NVIDIA GTX 580s, gaming cards, hardware you could buy at a store. It entered ImageNet, the big image recognition contest, where your score is how often the model guesses wrong. The lower, the better. AlexNet guessed wrong about 15% of the time. The next best team got it wrong 26% of the time. That gap was so enormous, researchers assumed something had broken. That accident unlocked everything that followed: large language models, real-time image generation, the entire AI wave running on chips designed for a completely different problem. The CPU didn't go anywhere. It still handles everything that needs order, logic, and careful decisions. But for the mountain of identical math that AI demands, the GPU had no competition. And from there, the idea only kept evolving. Google built the TPU, a chip made purely for AI. Not really a rival to the GPU, more like the next step down the same road. Apple and Qualcomm shrank that same idea into your phone. Every time your camera identifies a face without reaching the internet, that's a chip doing what GPUs taught the industry to do. So the next time someone says AI needs graphic chips, you now know why. We built the perfect machine for it, by accident, to play games.